Hello, everybody. This is your final exam math study. We're down to the wire, and I'm just going to talk through these problems. The handout is already on your Blackboard site, so you should be able to get that and follow along. The first couple of problems are pretty straightforward, and I think they'll feel pretty intuitive to you. You've done problems like this before. You've just got a newborn measuring in centimeters, and you want to know the length in inches. This does not ask for inches any more than just inches. So you'll just start with the 51.3 centimeters and then just do your conversion right in the middle, and you'll just come out with this bigger number here and 20.2 inches. This would round back to a 0, and then this would round to a 2. So you would not have a number here in the 100th position. So that's just the way that would be on that one. You have a healthcare provider that's ordered 500 milligrams IM, and you have 2 grams to be reconstituted with 10 milliliters. So ultimately you will have 2 grams in 10 milliliters. That's the amount that you'll have. You're going to start with your order, the 500 milligrams, convert right here to grams since what you have is in grams. And then you have the 2 grams in 10 milliliters. You're ready to do your math. It's just a straightforward question right there. Number 3 is a little less of a straightforward question. It's got a couple of pieces of information that you've probably seen in clinical but haven't seen on a test yet. But it does lay out all of the information. You have a daily recommended fluid requirement for children. It's 100 milliliters per kilogram for the first 10 kilograms, 50 milliliters per kilogram for the second 10 kilograms, and 20 milligrams per kilogram for every additional kilogram over that. What should the maintenance hourly rate be for an NPO child weighing 74 pounds? So the first thing you're going to do in that problem is convert the 74 pounds to kilograms. When you look at 33.64 kilograms, you know that the first 10 kilograms is going to be at 100 mils per kilogram. So you've got your first 10 kilograms right here, and that's going to be 1,000 milliliters. And then you're going to look at your second 10, which is from 10 to 20 kilograms, and that's going to go down to 10 kilograms to 50 milliliters. So you'll have 500 more milliliters. So the first 10 is 1,000. The second 10 is then 500. And then subtracting from the total of 33.64, those first 2 tens, then you have 13.64 kilograms left. And all of those will be multiplied by the 20 milligram per kilogram rate of 272.8 milliliters. And then you're simply going to add all those together. So the 1,000, the 500, the 272 is 1772.8 is the daily rate. And this asks the hourly rate. So you would divide the daily rate by the number of hours in a day, which is 24, and your milliliters per hour for your hourly rate would be 73.87. Going on down to number 4. You have a 21-month-old that weighs 12.4 kilograms. supposed to be giving medication, 750 milligrams every 24 hours and 200 milligrams every 6 hours. You've got your recommended dosage for both of the medications. And this question says, how would you round the weight for dosages to be safe? Well, you know that you've got 12.4 kilograms. And if you multiply or do the equation for 12.4 kilograms times the 60 milligrams for your 60 milligrams per kilogram dose, you're coming in just under, this would be the safe dose according to that, and that's just under the 750. So if you use the straight 12.4 kilograms to multiply, your order is not safe. But if you take that 12.4 and round the weight up to 13 kilograms with no tenths or hundredths, and then multiply it by the 60 milligrams per kilogram, then it does show that 780 milligrams is safe. And the order of 750 milligrams would then be within the safe range. The same thing with ibuprofen. Your 12.4 kilograms times your 16 milligrams per kilogram per dose is going to be 198.4 milligrams. Well, that's coming in again just under the ordered dose of 200 milligrams. So if you use the exact weight, 12.4 kilograms, then the ordered dose of 200 is not safe because 198 is the maximum safe dose. But again, if you round that weight up to 13 kilograms and then do your equation, 208 milligrams is safe. So then your order is safe. That's a little bit of a different question than what you've had before, but because it says if you round the weight, all you were going to do is you see this one's low, so you need to get it a little higher. So rounding the weight up to 13 is going to be the solution for that. Number 5, you have a 6-year-old who has an order for 425 milligrams every 8 hours. The medication is available in 1 gram vials. The directions say to add 5 milliliters, and your resultant solution will be 200 milligrams per milliliter. What volume should be withdrawn? So your order is 425. You have 200 milligrams per milliliter. You just do the math. That's a really straightforward kind of a, this is the order and how are you going to deliver that? This one's going to be the same type of a problem that you've seen before. Your patient has an order for 350 milligrams in 100 milliliter IV piggyback to run over 2 hours. The child weighs 70 pounds. The maximum dose is 50 milligrams per kilogram per day. So this is running every 6 hours, the 100, but this, when you figure it out, is going to be a full per day rate. The IV is infusing at 125 mils per hour and the tubing holds 15 mils. Based on the ordered dose, is the ordered dose safe? How would you set your secondary pump? So you're first going to convert from the 70 pounds to your kilograms. And then this is the maximum dose in a day. So 1591 milligrams in a full day is going to be the maximum dose. which would be 397.75 milligrams per dose, because you're giving it every 6 hours, so that would be 4 times in a day. So the 350, which is ordered, is safe. You're going to set your secondary pump. You're running 100 mils in 2 hours. So if you start with your 1 hour rate, you will find that you're running 50 mils in an hour. And then the whole 100 will run in 2 hours. But then you have to clear the tubing. So your total volume will be 115 milliliters. So the first hour, 50 will run in. The second hour, 50 will run in. And just a little bit into the third hour, that extra 15 will continue running in at the 50 mil per hour rate. And then it will revert back to the primary. Here you have a toddler that needs 15 micrograms per kilogram per day divided into 2 doses. So this will be your full day rate. You're going to give it in 2 doses. And this is how the mixture comes, 75 mics per mil. And how much will the child get per dose? So make sure you're watching for those full day rates and then the per dose rates. So you're going to convert first, or just incorporate this right into the equation, what your number of kilograms is, and then 15 mics per day. And this is what it equals, 170.45 micrograms per day. And then you're going to divide that by the 2 doses. So 85.23 micrograms per dose is what you get when you divide this by the 2. And 75 micrograms comes in each milliliter. So how much will the child get per dose? This is the per dose amount. It's going to be 1.14 milliliters. The next one, you need to give a 200 milligram IV antibiotic over 1 hour on a mini infuser. The recommended minimum dilution is 15 milligrams per milliliter. If the medication comes up in 5 milliliter solution, how fast will the IV need to be running per hour to make the delivery safe? First, you're going to see how many milliliters you have to dilute the 200 milligrams with. If the most that you can have is 15 milligrams in 1 milliliter. So you'll find that you'll need 13.33 milliliters to dilute this 200 milligrams. So the 13.33 milliliters per hour minus the 5 milliliters of solution you're going to be running the IV at 8.33 mils per hour. This is another problem like you had on the last test, where you're going to have an IV infusing at 15 mils per hour. and you have 100 milliliter IV piggyback ordered, and it's safe to give over 15 to 30 minutes, and you need to give it at 9 a.m. The tubing holds 15 mils, so you set the rate at 200 mils per hour, and that indicates to you that the 100 mil piggyback is going to be given in 30 minutes as opposed to the 15, because you're setting your rate to 200 per hour, and the volume to be infused at 115. So your total volume infused will be 115. Your IV will run at 200 for this 30 minutes for that 100, and then for a little bit longer for the extra 15. And then it will revert back to the 15 mils per hour primary rate. So from 8 to 9, you're just going to have 15 mils per hour. This is how you would chart your INOs. You'd have 15 mils per hour. At 9 o'clock, you're going to have the 15 mils run in from the tubing, and we'll have to figure that out in number of minutes. You'll have the 100 mils run in from the IV piggyback, and then you'll have the remainder of the time, which is going to be 25.5 minutes once we figure it out, for it to revert back to that 15 mils. So what you're first going to do is just take this piggyback, the 100 milliliters, and from 9 to 9:30, that's what's going to be running. And then you want to find out if the fluid is running at 200 milliliters per hour, how many minutes will it take for this 15 to run in? So you're going to start with your 15 milliliters and just put that over the placeholder of 1. And then if you have 200 milliliters running in an hour, then you'll put 1 hour over 200 milliliters. And then in the next position, you'll put 60 minutes over 1 hour. So on that problem, you'll ultimately have 50 times 60, the 60 minutes, and then you'll divide by 200 for the milliliters, and that will be 4.5 minutes that it will take for that 15 milliliters to run in if you're running your IV at 200 mils per hour. And 30 minutes minus 4.5 minutes is going to be 25.5 minutes. And so the next part of that equation, you're going to start with 25 minutes over 1. And now you've gone back to your 15 milliliters per hour. So you've got 25 minutes. You're going to convert that to the hour rate. So you'll have 1 hour over 60 minutes. And then in the next position, you'll have 15 milliliters over 1 hour. So you'll multiply the 25.5 minutes times 15 milliliters. And then you'll divide by the 60 minutes from your conversion for your 1 hour to your minutes. And you'll get 6.375, and you'll just call that 6.38 milliliters is what's going to run in between the time that this 15 finishes running and 10 o'clock. So these two added together are 21.38 milliliters is what you have running from the IV with your tubing, and then the primary, and then this is your IV piggyback. And then at 10 o'clock, you'll just go back to a straight primary rate. Work through those problems and make sure that you can write them out and that you're familiar with what they're asking. And we will set up a Zoom meeting probably on that Monday before the final, which actually is going to be next Monday. So we'll plan to do that at 2:30 and go through these problems. And then if there are questions, we can look at those at that time.